Good morning class. Today topic is problem solving of the exercise 5.1. In this exercise first question already solved in last lecture. Today I am taking the question number 3rd. This question very important questions. Question here, examine the following function for the continuity. Means some function here given or you will examine only, not prove that, not find the value, only examine the given function is continued or not. How to examine this? In this question solve, you have pre-knowledge of the property of the continuity. If you have this pre-knowledge, then very easy to solve, otherwise very problem. First things, here different type function is given. Which function is continuous? The last lecture I explained these things, which function is continuous or which function is not continuous. Now observe this first here, solution start here. First here, if solution fx equal x minus 5. Now look this, fx is equal to x minus 6. X minus 5 is which type of function? This function is the polynomial function. From property you will learn it. Every polynomial function is continuous. So then you can say if this f equal to 5 is a, you will write your name polynomial function. So then means suppose this function is the polynomial, then you can write here this function is continuous. So f is continuous for all values of x. This is your answer. Means only, but keep in mind this thing, which type of function of this. If you have learned, then write name of the function and then write here your result. What result comes this function? But this is the polynomial function, then you can write here f is continuous for all values of the x. Every value of the x means this function, every value will be continuous. Now second part, b part here. This is fx equal 1 upon x minus 5. Then we write here this function is a constant and this is the polynomial. So whole making the two polynomial functions here. That means this function is the polynomial function and every polynomial function is the continuous. So this is, you write here this is a quotient function one upon x is a quotient function of two polynomial. Polynomial functions. So then you can write here, so f is continuous. F is continuous for all values of x except x equal 5. Means this function, suppose you are putting here x equal to 5, then this value come here x equal to, when you putting the x equal to 5 and 5, this will become 1 upon 0 or 0 equal to infinite. Infinite is not continuous. Infinite is not continuous. Means f is continuous for all values of the x. F is continuous for all values of the x except x equal to 5. Means only value of the 5 is not continuous, all other values will be continuous. So this is B part is completed. This is the answer of the B part. Next C part here, fx equal x square minus 25 upon x plus 5. Now look here, suppose you are directly solve this, this will be polynomial function, this also polynomial function. every polynomial function is the continuous. This function is the continuous, but you solve first, then you write here. So now what solution of this? X square minus 5 square, and using the property of a plus b and a minus b, what result come here? X plus 5, x minus 5. The result here come x plus 5 will be cancelled here. Result come x minus 5. The value of the function is fx equal x minus 5. I mean this is the polynomial function. Same that this first part and third part is the same that here. Fx equal to x minus 5, fx equal to x minus 5. So means this is the polynomial function. This is the polynomial function. F is continuous for all values of the x. Next. Now first, second, third part you are already solved it. Then last part here. Function fx equal to here f. This function is not polynomial. This is the modulus function. So how to solve the modulus function? Now look here. The solution here. D part fx equal mod x minus 5. According to properties, not write that modulus function. Every modulus function is the continuous. This is not clear. Then you solve it and check this continuous or not. So now first I will check this. The modulus function convert in x minus 5 value for when x greater than equal to 5 and minus x minus 5 value for x less than 5. Means this modulus function having two types, positive and negative value. Positive and negative value. The positive value always come when putting the 5 and more than 5 value in this function, then always come in the positive value in this function. And second, if you putting here less than 5 value here, then come in the negative value. That means every modulus function converting two type values, positive and negative. So then you will check here at point 5 this function is continuous or not at point 5. So now check this at x equal to 5. Similarly, checking method here, LHL equal limit x tend to 5 from x tend to 5 from left side, then function limit x tend to 5 negative sign represent here from left hand side. Now look which function, what value of the fx here from left hand side. So this value will be always come in the right hand side. This is the positive value always come in the right side of the quadrant. And next, this value always come in, negative value always come in the left side. So means the function will be used this function. So now I will write a minus x minus 5. So we can write also here x limit x tend to from negative value and 5 minus x. Multiply inside this, then converting positive one. Again limit x tend to 0 toward the origin. This x converted to x towards 0 and this 5 minus x. So what value of the x here? 5 minus h. 5 minus h. In x place we are changing the 5 minus h. H tend to 0 here. And then we are putting here 5 minus 5 0 and then plus h. The result will become here 0. Using the limit, then convert here value is 0. Similarly, using RHL, limit x tend to 5 from right side, positive sign represent from right side, then limit x tend to 5 from right side. Means now look, this value will be come in the left side, this value will come the right side, positive value from right side. The function will be here x minus 5. So there's limit s, again same here, s tend to 0 here, then s tend to 0, this 5 convert here 5 plus h minus 5. This are here from right hand side the value converting positive sign, and from LHS side this converting negative sign. So remember this always. Next, so this minus this result will become 0. It means two values are same, LHL and RHL. but this is not sufficient. Now you find the one more value here. What values? Function values. Now what value of fx equal mod x minus 5, x minus 5. Then we are checking here x minus 5, add x equal to 5, add x equal to 5, that means 5 minus 5, this will be 0, result will become 0. The third three value are same, this and this value. So then you can say here, if this function here, this function continuous at x equal to 5, not odd value, the x equal to 5. So now means LHL means you are writing here fx. So limit x tend to 5 from left side fx and limit x tend to 5 from right side fx equal f5. So these are three values equal, then you can say this function is continuous at x equal to 5. Now the next question is very simple question. Next question will start. Yes, student, next question I am taking the question number 5th, same exercise 5.1. Here given is the function f defined by this function fx equal to this x if x less than equal to a 1 and 5 value of the function 5 when if x greater than 1. In this type question, and you will check here continuous at x equal to 0 means this function x equal to 0 continuous or not. Second answer will become at x equal to 1 this function continuous or not. Third answer at x equal to 2. In the three answer will become here first 0, second 1 and third x equal to 2. So now start question. Solution here at first part here at x equal to 0. I am taking this part. Same process here. Same process. First I will check LHL. Limit x tend to 0 from left side and function. Limit x tend to 0 from left side. What value of the function here? What value of the fx here? Means from LHL. So this value always come in the positive side, means greater than 1. X greater than 1 means 5. So this value always come in the more than 1, 2, 3, 4, 5. This 5 will become if value of the x 2, 3, 4, 5, 6. If value of the x 2, 3, 4, 5, then function value of the 5. If value of the function 1, 0, minus 1, minus 2, minus 3, then value of the function here x. If value of the x, where value of the x here 0, minus 1, plus 1 also 1, minus 2, minus 3, then so then value of the function here fx equal to x. When x equal to more than 1, 2, 3, 4, 5, then function value of the function equal to here 5. Keep in mind this two types. So here when I am taking the left of the 0, then function always come here x. So this will become here limit s tend to 0. So this 0 represent the from left hand side and this 0 is from toward the origin. And then it convert the 0 minus h. This 0, this limit convert into here and s convert here in x place. So the result will become 0. Similarly, I will check in RHL. Right hand limit x tend to 0 toward the origin, positive direction the origin, then limit x tend to 0 positive direction of the origin, and what value are this is a 0, but 0 also come here in function here x. So we will convert here limit s tend to 0. Here not write positive, then we convert here 0 plus h. Plus sign represent here from a right hand side, or negative sign represent here from approach, minus sign represent approaching to the origin from left hand side, and positive sign represent here approaching to the origin from right hand side. So that result also come here 0. And if two answer came here same, then third answer here. What value of the function? Suppose fx here x. Then f0 are using f0 here 0, then using here 0. The three values can be same, means LHL, RHL and value of the function are same. Then you can say here the limit x tend to from left side function equal to limit x tend to from right side function equal to f0, means three values are equal. Then you can see here to so f is continuous at x equal to 0. And we can say here this function is continuous at x equal to 0. This function is continuous. Now I will check again this at x equal to 1. I will check this side again, not down it. Yes student, first part is completed. Now I am taking the second part here at x equal to 1. At x equal to 1. I am solving in this part, second part. The same process here, LHL, RHL and function. First I will take LHL, limit x tend to 1 from left side function and limit x tend to 1 from left side. What value of the one? Left side value of the function x here. This will be converted in limit x tend to 0 and 1 minus. This here limit 1 to 1 minus h. Limit here 1 to 1 minus h. Convert using the limit here, then we will come here plus 1. Very simple things here. Function is left side of the 1. Left side of the 1 means function will be count here x. Similarly here RHL, limit from right side of fx, the limit from right side from 1. Now look here, value of the function is x when x equal to maximum value 1, not right side. That means maximum value of the 1. Suppose you have 0, 1, 2. Up suppose we are using the left side one, maximum value of 1 is count here means left side here. For right side, suppose you are using the maximum 2. When you moving from right side, then means 2. Moving from 2 to 1, so then your function is count here 5. Because your maximum value of the here, this function x is maximum 1, or more than 1 means 5. So you are using right side of the 1. The right side of the 1 means this is the right side of the 1. This is the RHS. This is the LHS. The right side one means more than 1. Right side one means more than 1. Then you can use the more than 1 means function will be 5 here. Here constant function, constant value here, then you are not need to convert it to h. So this is from already value here h. So now compare both value here. LHL 1 and RHL is 5. Both are not equal. Then no need value of the function of next third value. No need it. But then you can write here. So you can write here LHL does not equal RHL. So f is not continuous at x equal to 1. This is your answer. Means this function is not continuous at x equal to 1. Because LHL or RHL is not equal, then no need the third values. Then you can write the answer here. That's not equal and function is not continuous, discontinuous. But then third part, I'm taking the third part here. First and second part completed. Now I'm taking the third part here. X equal to at x equal to 2. The same process here. How to solve that? X equal to 2. Now start the solution here. At x equal to 2. Same process. First I'll find the LHL, the limit x tend to 2 from left side fx, limit x tend to 2 from left side. What value of the function here? Means 2. This is the 1 and less than 1. So this function is not valid. So now this function, when value of the x is 2, 3, 4 and more than, then value of the fx equal to always 5. Then we are using the left side to means using this. Then we are what value of function is 5. What value of the last? We are not any value of the variable number, then directly you write 5. Similarly, find the RHL. Means limit x tend to positive from right side, left side 2 and right side 2. Means suppose your number write 1 and 2 and 3 here. The left side 2 and right side 2. The approaching value here 2. Then function here, this will be limit x tend to right side. This value also same here for plus 5 and this will also come here 5. So means LHL and RHL are same here. Then need third value here. If a function is f2, what value of the f2 here? When x equal to 2, then function equal to 5 here. This directly here. When putting the suppose x equal to 1, the value of the function is x. When putting the value of equal to 2, then value of the 5. When putting the value of 3, then value function of the 5. And this is value of the 4, 1 and this 2 value of 3 and more than all values for the more than 1 function is the 5 here. We are f equal to 2, then function will be 5. Means LHL, RHL and value of the function is same. Then you can say here if this is continuous. So now the limit x tend to 2 from left side function equal to limit x tend to 2 from right side function equal f2 function. So f is continuous at x equal to 2. Means this function is continuous. This function is continuous at x equal to 2. RHL value equal RHL value and this function is f2. Now directly here no any variables number, directly value f2. f1, if you are putting the f1, then convert function is the x. 2, 3, 4, 5 value is the 5. Always come 5. This is the domain, this is the codomain. So when you putting the 2, 3, 4, 5, the value of function is the always 5. In more than one, every number function value is the 5, and 1 and less than value of the function is x. So this is your this function is the continuous at x equal to 2 and x equal to 0, but not continuous at x equal to 1. So not on is this is the simple question.